dear students and parents. We are from VISHRA, IIT JEE and NEET Academy. We welcome all of you for the paper discussion of the 29th evening session. Okay, I am the senior most chemistry lecturer here. My name is SRIKANTH SUNIL. We are going to take up the question paper process and we are going to solve the process one after another. So, all of you, once I want to tell about my academy. My academy was started in 2014 and till now simultaneously we are producing lot of IIT JEE ranks at the advanced level and also at the mains level. So, we would like all of you, those who are seeking admission into the first year or into the second year, please visit our campus. Our campus is in Hyderabad near Balapur X roads, and we have the co-education for girls, boys, separate hostels as well as day scholar also. So, let us go into the paper discussion. Welcome all of you. Now, I am going to discuss the evening session paper of 29th Jan, which was on 2024. So, all of you welcome. The first question, I am going to teach chemistry, so I will discuss the chemistry part of it. Okay. So, let us see the first question. Question number 1. Question number 1. Okay. They are asking about a reducing agent. They are asking about a reducing agent. Yes, let us see what is a reducing agent. See, if the oxidation number increases, if the oxidation number increases, it can act as a reducing agent. It can act as a reducing agent. Here they have given us 4 options. These are all options from the lanthanides. See the options. First one is cerium with 4 plus charge. Second one is GD, the gadolinium, which is 2 plus. Third one is potassium, which is also 3 plus, and ND with 3 plus. See, first option, fourth option and third option, there is no possibility for these ions to increase their oxidation state. So, if you take gadolinium, gadolinium is the center atom of the lanthanides. This will have the configuration xenon with 5D1 4F7. So, this one is GD2 plus and this can increase to GD3 plus easily by removing this electron. We can easily go to 3 plus. So, then it becomes 4F7. Of course, it is a very stable configuration. So, there is possibility for gadolinium to increase to 2 plus to 3 plus. So, this one among these 4 can act as a reducing agent and it can increase its oxidation state. So, option should be number 2. So, it is a very simple question. This is from the D and F block elements, actually talking about the F block elements, we can say lanthanides and their electronic configuration related question. Okay, students, we will go to the second question. Second question is from organic chemistry. Let us see the 4 options given. First option, First option. First option is there is an amide this is the amide. So, to this we are doing bromination Br2 in the presence of NaOH, and then we will get CH3 CH2 CH2 NH2. This is an amine. So, we are converting a amide into amine. That is the first option. Second option. First, let us see the options. Second option, there is a ring with unsaturation here, and to this we are doing bromination in the presence of UV light, and we will get the compound, expected compound is like this. Third option. An amine CH3 CH2 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 NH2. This is an amine, and we are using nitrous acid HNO2 in the presence of 0 to 5 degrees Celsius temperature, and we are getting an alcohol 1, 2, 3, 4 and OH. Understand the hydrogens like this. This is the third option. Let us see the fourth option. Fourth option is there is an unsaturated cyclohexene with a bond like this. We will have CH3 here, and to this we are adding hydrogen iodide. Hydrogen iodide we are adding, and then we will get the compound like this. So, these are the four options that we are giving for the second one. The question is, which of the option is correct? There are three options which are wrong and one is correct. So, we have to choose from them. So, let us see here. So, this is bromine addition. So, it's in bromine addition, actually how many carbons are there? 3 carbons are there. Here also we are getting 3 carbons. Same number of carbons we will not get. This is a degradation process, Hoffman bromide degradation. So, we will get only 2 carbon compounds. So, this will be correct if CH3, CH2, NH2 is there. This would be correct, but they gave this, so this is not the correct option. Number of carbons will decrease. So, let us see this. Second one. This one is an unsaturated compound. In this unsaturated compound, this part, okay, this part is most important. This one is allyl carbon. This one is allyl carbon. What is an allyl carbon? Carbon, double bond carbon having one more carbon, which is an sp3 carbon attached to the unsaturated sp2 and sp2 carbon. Right? So, these two positions are allyl positions. So, everyone will think that whenever you take Br2 will attach bromine here and bromine here. This is not simple addition. This is a substitution reaction. So, what happens? Bromine here or here it is going to attach. So, expected compound we are going to get like this. We are going to get bromine in the allyl position. So, either this carbon or this carbon. So, this option is not correct. So, first one and second one are also wrong options. Let us go to the third one. Third one, all of you see here, this is amine, and 0 to 5 degrees ice cold conditions, nitrous acid means this one is diazotization. This one is what? Diazotization. So, in diazotization, what we are going to get? Diazonium salt we are expecting. Diazonium salt we are expecting. So, we are not getting a diazonium salt here. This is a 1 degree amine. and we are not going to get this compound. So, let us go to this one, fourth one. Fourth option should be the correct option. This one is also not the correct option. So, here the electrons will move to this side. When electrons move to this side, you will have a plus sign here. 3-degree carbocation is formed, and then because of the 3-degree carbocation, I minus is going to attach this position. So, we are going to I minus here in this position, and that is how we can explain the option which is correct. This is basically an organic chemistry compound covering all this, mostly bromination and diazotization and also hydrogen iodide addition, and particularly here 3-degree carbocation is more stable. So, T-degree carbocation will be formed and I minus will be attached to that. That is how we can explain the second option. Okay. Question, very simple basic question from organic chemistry based on IUPAC nomenclature. So, I think most of the students can attempt this and easily crack this question. So, let us see the third question. Third question. Yeah, I am going to write the third question. All of you observe this. Very simple compound. We have to write the IUPAC name of this. Very simple. So, this one is cyclohexane. So, we can write cyclohexane here, but there is a double bond. So, we can write cyclohex and there is a double bond and there is a OH group. We have to see that OH group is having top priority. So, numbering we are going to do from here, number 1 here, number 2 here, number 3 here. So, double bond comes on the second numbered carbon. So, hex 2 in and this one is 1 all. So, we can remove this particular E here, we can remove this, okay, and we can just write the N here. So, cyclohex 2 in 1 all is the name of this compound. There are many other options which are not correct. So, I do not want to write all the options, this is the correct option, and in fact, in the question paper this option is at the second option. So, you can give the second option. They give different types of names which are not correct at all. So, you should be able to understand where the suffix is there, where is the word root, where is the cyclo word we are using, where we are applying the secondary suffix, where we are applying the primary suffix, all this we have to see. So, this is option 2 in the question paper. Actually, the name is cyclohex 2 in 1 all. Question number 4. This is also very simple question from periodic classification. Why does oxygen show anomalous behavior? Oxygen in its particular group shows anomalous behavior. Why so special oxygen is when compared to the other elements, we have to explain. So, in this all of you know that oxygen belongs to the 6th A group elements, and it is a small atom, high electronegativity. These are the main reasons. High electronegativity, of course, in electronegativity after fluorine, oxygen is the second ranked high electronegative atom. So, after the small size, most important point is high electronegativity, and let us see the electronic configuration. Oxygen is having electronic configuration 1s2, 2s2, 2p, 2p4, 1s2, 2s2, 2p4. Uh, 1s2, 2s2, 2p4. So, in 1s2, 2s2, 2p4, there is no 2d0. So, it cannot expand, no expansion or extension of configuration. These are the three reasons, main reasons. So, based on the options, let us see the options. First option, large size, high electronegativity, wrong option. Second option, small size, less electronegativity, that is also wrong. Third option, small size, high electronegativity and absence of vacant d orbitals. So, these d orbitals are not present, so it cannot expand its configuration or extend its configuration. So, 2p only will be the last, it cannot show more and more oxidation states. That is most important point. And the fourth one is large size, high electronegativity, presence of vacant d orbitals, which is wrong. So, first option, second option and fourth option are wrong. Third option is exactly what we have explained. So, third option is the correct option. Go to the fifth question, dear students. This is from atomic structure, very easy, based on the line spectrum of hydrogen. So, let us see. Let us close this, clear this. Let us go to the fifth question. Number 5. Question number 5. Very easy, it is like a multiple choice question. Let us observe this. First they gave A and this one is a Lyman series. B they gave, it is a Balmer series. And C they gave as Paschen series. And D is the Fund series. Okay, or P Fund series, P is a silent, so we will say Fund series. Now, opposite to this, they have given 1, 2, 3, 4 to match the following. First one is infrared region, second option is also infrared region, third one is visible region, and fourth one is ultraviolet region. Even the basics students who are studying atomic structure, they can answer this very, very easy question. So, we know that Lyman series is lines are produced in the UV region. Balmer series is the only series which we can see. So, these are in visible region. Of course, this Paschen as well as Fund series both are in the infrared region. We can say 1, 2 or 2, 1, anything is correct. So, in the options, they gave A with 4 and B with 3 and C with 1 and D with 2. So, this option is the correct option. Very simple from the line spectrum of hydrogen. Students will go to the sixth question. All these questions are very easy, easily you can answer them. Don't worry, your upcoming sessions are also going to be at this level only, don't worry about that. So, we will go to the sixth question. This sixth question is from the complex compounds or coordination compounds. So, let us see, very simple question this one also, but you have to answer carefully. So, we will clear this and we will go to this. Yeah, this one is the sixth question. Question number 6. We know this potassium manganate K2MnO4, potassium permanganate KMnO4, potassium manganate K2MnO4. We have to write the IUPAC nomenclature of this complex compound. In fact, this complex compound can be treated like this. Actually, we can write this complex like this. And these are the other ions which are outside the coordination sphere. This is the coordination sphere. We can write this is a complex compound. So, you can write the name of this compound See, first of all, if you want to write the name of this compound, we have to know the oxidation state. This one is +6 oxidation state. +6 oxidation state. So, using this +6 oxidation state, we are now going to name this compound. So, this compound, first cation name potassium, then anion. In that anion, coordination entity is there. So, we have to write manganate. So, we have to add the suffix ate whenever this one is in the negative part or the anion part. If it is in the cation part, no need to add. So, we have to write the suffix ate and we have to write the oxidation number in Roman figure. Sorry. Six manganate. Then there are 4 oxygen ligands. So, tetraoxo. Of course, I gave some gaps, so we should write continuously. Potassium tetraoxo manganate 6 is the IUPAC name of this K2MnO4, which is generally known as potassium manganate. Okay, students. So, option will be potassium tetraoxo manganate 6, right? Students, we will go to the 7th question. I think all the 6 questions are very easy for you. You can do all these questions very easily, and when you are preparing for your session also, see that all these points are covered, brush up all the important points and go to your examination with all the formulas. So, these questions, I can say that they are basically from the NCERT, is it not? They are basically from the NCERT book, and those who are very thorough with the basic principles and those who are very thorough in the textbook reading, they can easily crack all these questions easily. So, no problem, all of you refer to all the formulas, all the electronic configurations, all the different types of simple points which are given in NCERT, all the formulas, all the IUPAC nomenclatures, and then you go, you can easily write the examination without any fear. So, we will go to the 7th one. 7th one is based on a combination of named reaction. This is an organic chemistry question. Organic chemistry, we have 2 named reactions. Diazotization reaction, already we got in some 4th or 3rd question, and with the diazotization we should understand what is Sand-Meyer reaction. With the combination of these 2, this question is there. So, let us see what is this question. I want to write the question here. This one is question number 7. Question number 7, dear students, question number 7. Yes. Question number 7 is like this. We have taken aniline. Aniline is a 1 degree amine, which is aromatic amine, but it is a 1 degree or primary amine. On this, they are adding HNO2 in the presence of 0 to 5 degrees temperature, nitrous acid, and then this one is the first step. Second step also they are giving. This second step is Cu2Cl2, cuprous chloride in the presence of HCl. So, what is the compound that we are going to get here? That is the question. What is the compound that we are going to? So, let me explain the conceptual part of this simply, then we can see the answer and you can easily tell the answer also. So, let us see. First, any 1 degree or primary amine when you add NaNO2 in the presence of HCl, NaNO2 in the presence of HCl. These two will combine and give actually HNO2. HNO2 is not directly added. This is a combination of sodium nitrite and hydrogen chloride, and of course temperature, ice cold temperature 0 to 5 degrees, not more than 5 degrees, this compound will be unstable, it will break. So this one gives a diazonium salt, it will give a diazonium salt. What is this? If this compound is taken, what will be happening? So this one is aniline. Is it 1 degree? Is it 1 degree? Yes, it is 1 degree because NH2 is there attached to only one carbon, 1 degree are primary amine to this. First let us say HNO2, which is a combination of these two at 0 to 5 degrees Celsius, and then we will get diazonium chloride because we are using HCl here, expected is diazonium chloride, N2Cl. Diazonium chloride is obtained, and diazonium chloride if you take according to the Sand-Meyer reaction, you take CuCl or Cu2Cl2, anything copper should be in +1 oxidation state. It should be a copper salt, and copper should be in which oxidation state? +1 oxidation state. Then immediately in the presence of HCl also combination, this one is going to give you chlorobenzene. Chlorobenzene. This one is a Sand-Meyer reaction. Sand-Meyer preparation of aryl halides. This one is diazotization. These two are very important and simple name reactions from the second year part of our NCERT. So using this, you can write the compound will be here we gave a question mark now. So instead of the question mark, the answer will be chlorobenzene. Answer will be chlorobenzene. So easily you can write the chlorobenzene. So option we have to select chlorobenzene. They will be giving different types of options. I don't want to write all of them. So the correct answer is chlorobenzene. So dear students, all of you study nearly 35 to 40 named reactions are there in the first year as well as second year organic chemistry, junior and senior organic chemistry. All of you refer to that before going to the examination. We can expect 1 or 2 questions from that, and 1 or 2 questions is going to do a lot of good deal for us in the marks. To the question number 8, one more very easy question, basic question. We can see this in the foundation for 9th and 10th class also. Which of the following element has highest first ionization energy? All of you know the first ionization energy is the energy that is required to remove a loosely bound electron from the outermost shell of a gaseous neutral atom. So we have to understand all the options in the gaseous phase and understand their electronic configuration, and which electronic configuration is a stable electronic configuration, that one will be the answer. So question is, which among the following has the high ionization potential, first ionization potential? So let us see, we can say IP1, first ionization potential, we can say IP1. So which option is having more? Let us see. First one is nitrogen, second one is carbon, third one is silicon, and fourth one is aluminum. Very easy. Nitrogen, which belongs to the 5th A group, carbon belongs to 4th A group, aluminum belongs to 3rd A group, and of course silicon belongs to carbon group only, so 5th A group. So in this we know that nitrogen has the stable half filled electronic configuration. So let us explain that. Option will be the first one, which will have high ionization potential, number 1. So let us see, nitrogen electronic configuration 1s2, 2s2, 2p3. This one is half filled stable configuration, half filled stable configuration. So first electron, if you want to remove, you can easily remove from carbon or silicon or aluminum. But when you compare the electronic configuration of these three with this, then it will be very, very difficult, because it is a stable configuration. It will resist giving the electron, so the IP will be high, IP1 will be high. So, the option is nitrogen among these four. If any other option is given also, check the electronic configuration, check whether they are giving ionization potential 1 or 2 or 3, and based on that try to solve the question. It will be very easy, because these questions are from the periodic classification, the basics of inorganic chemistry. Okay, student. Ninth question is a bit difficult question, I will say. I will not say difficult question, it is a moderate question. When compared to these questions which we have solved till now, this question is slightly better question and slightly difficult, because this question comes from the practical chemistry, and the Nessler's reagent, all these things are coming in the practical chemistry of this. So, when we do the practicals, generally we see the Nessler's reagent and the other reagents. So, let us go to the question and let us try to answer the question. So, all of you carefully understand. I will give the structure of the compound also. It is slightly typical structure. So, hope you will all follow. So, let us see the question. Let me erase this. Okay. Question number 9. Question number 9. See this question. Which reagent gives bright red color? This bright red color is also known as a cherry like red color. Generally they say like this, because it is very bright, with Ni2 plus ion, nickel 2 plus ion in basic medium. Students, to answer this question, we have to refer to the practical chemistry and the table in which nickel ions are there, nickel salts, we have to study that. But anyhow, I am going to suggest you to study all the groups and all the radicals, basic radicals and acidic radicals, and their conformation tests for the practical examination before going that. Let us see the options. First one is dimethyl glyoxane, DMG. This is DMG. Second one is Nessler's reagent. This is a potassium salt of mercury in iodine, K2HgI4. So, this one is Nessler's reagent, a common reagent that we are using. Then the third one, potassium thiocyanate, KCNS, and the fourth one is our common compound K4FeCN taken 6 times. Potassium ferrocyanide. So, these are the options that are given, and I would like to tell you, this one is a direct question. If you know the practical chemistry, you can say DMG, dimethyl glyoxane, is the answer for that. It gives a cherry red color for nickel 2 plus ion, and we can identify the nickel ions also. So, let us see what is this compound. Okay, this compound is DMG. I am explaining here the structure of DMG. CH3 attached to carbon and carbon, here CH3, and here there is a double bond with NOH, here there is a double bond with NOH. This is a dimethylglyoxime. This one is an oxime. This is a dimethylglyoxime. So this compound, when it reacts with nickel, NiCl2, let us say, in which Ni plus 2 is there. Let us see NiCl2. Then what happens? Let us see the structure. Carefully, I would like to draw the structure. See all of you. N, double bond, carbon, single bond carbon, and N. And there is a CH3 group here, and there is a CH3 group here. Same group will be repeated that side also. N, double bond carbon, single bond carbon, double bond N, and there is a CH3 here, and there is a CH3 here. And there is a nickel at the center, there is a day2 bond, and there is a day2 bond here. These are the normal bonds that we are suggesting. Nitrogen with a pair of electrons here, and this one is the bond that we are suggesting, and we have a O. This one is the structure. This structure is a cherry or bright red color. So this one is a test for nickel, so we can use it as a test for nickel in the practicals. So students, I think all of you understood the 9th question. So all of you study the simple principles of the tables which are there in the practical organic chemistry and practical inorganic chemistry. What are the basic radicals, what are the acidic radicals. Carefully understand all this and try to answer that before going to the examination. Okay. Right. The 10th question is from the biomolecules chapter. In the biomolecules chapter, all of you know we study about starch, cellulose, glucose, amino acids, proteins, all these. So based on this only the question is there. So very simple, they are giving the polymer and they are asking to identify the monomer. So let us see the question number 10. Question number 10. So it is also the match the following type. So let us see A, B, C, D. This one is starch. This one is cellulose. And this one is nucleic acid, and this one is protein. And now you have the options that are to be matched properly. So see the options that are, first one is beta glucose, second one is a nucleotide linkages, and there is a alpha glucose, and there is alpha amino acid. So these are the monomers. You have to match the monomer which is giving the polymer. These are actually the biopolymers. Okay students, so starch will have the alpha glucose, cellulose will have the beta glucose, nucleic acids will have the nucleotides, proteins obviously they will have alpha amino acids which are combining to give finally protein. So in the protein structure basic compounds that we are combining are alpha amino acids. So let us see, A is matched with 3 and B is matched with 1, C is matched with 2 and D is matched with 4. This is the correct option, dear students, for the match the following of this. Okay students. So we have one more organic chemistry question which is also very easy. It is based on the geometrical isomerism. It's a combination of geometrical isomerism and organic chemistry, and particularly organic chemistry in cyclic compounds. So let us see the question and how we can answer that, let us see. Which of the following compounds, they gave 1, 2, 3, 4 are A, B, C, D options. Which of the following are exhibiting geometrical isomerism? You have to see and you have to identify the compound. So, let us see 11th one. So, there are 4 options. Let us see the first one. This one is third option also I am writing. Fourth option. Okay, students, in this, let us see. Carbon double bond carbon, 2 same groups, no geometrical isomerism. Carbon double bond carbon, 2 same groups, no geometrical isomerism. Here there are 2 different groups, but it is completely symmetrical. You can observe that side and this side. If you change also, same compound is there. So, it is symmetrical. So, symmetrical means leaving this group, this particular group, I am saying that this one is in para position. So, this one can exhibit the geometrical isomerism. So, let us see the geometrical isomers. Geometrical isomers. So, let us see. First geometrical isomer is like this. This one is like this, and the second geometrical isomer can be like this. These are the 2 geometrical isomers. So, here what happens is, even hydrogen is this side or bromine is that side. This bromine is exactly opposite to that, and this one is not showing no geometrical isomerism in this case also. So, option will be 4. This one exhibits geometrical isomerism. Dear students, I think you understood, right? Question number 12. It is also a very easy question, once again from organic chemistry, and this is from haloalkanes. So, haloalkanes, let us see. So, the question is, 12th one, question is, you have to convert alkyl halide to alkyl isocyanide. Alkyl halide to alkyl isocyanide. What are the options? First one is KCN, second one is AgCN, third one is KNO2, fourth one is AgNO2. Okay, dear students, isocyanide, this one is the correct option. So, I am taking the alkyl halide like this, RX is the alkyl halide. So, first let me react with KCN, and this one is supposed to give RCN, this one is cyanide. And if you take RX and if you react with AgCN, This one is going to give you isocyanate. So, this one is the correct option. Let us see the third one also. Rx when reacts with KNO2, this one is going to give a nitrite compound, nitrite. And Rx when combines with AgNO2, this one gives a nitro compound. So, option B, option 2 is the correct one. That is why for the 12th one, to convert alkyl halide to alkyl isocyanate, we use AgCN as the reagent. Understood, dear students? The 13th question, the next question, again a simple chemical bonding question, but a organic compound is given. So, let us see how we can understand this. There is a compound like this, O attached to H, attached to C, double bond O. This is an acid with a carbon, and there is a hydrogen here, and there is a C, double bond O, and there is a H here, and then this one is O. So, this one is CH2, CH double bond, CH single bond, CH2. This one is the compound, and you have to count the number of sigma bonds. Sigma bonds in this, how many are there? Pi bonds in this, how many are there? So, try to count the sigma bonds. Sigma bonds, you are getting 19 sigma bonds, and you will get 3 pi bonds. Count all this. Even carbon hydrogen bonds are sigma bonds. Dear students, carbon hydrogen bonds are sigma bonds. Pi bonds, here 1, 2 and 3. Okay. Sigma bonds 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 and 19. So, this one is the correct option. So, select the option which has sigma bonds 19 and pi bonds 3. So, you should be able to write the structure of the compound carefully. Okay, students? Students, we will go to the 14th question of this session. Gas X is added to Nessler's reagent. Now, we will get the formula of Nessler's reagent, then brown precipitate is formed. The gas X is, it is ammonia. Dear students, let us see the reaction. Gas X is added to Nessler's reagent. Gas X is added to Nessler's reagent, then brown precipitate is formed. What is X? So, they have given us the options. First one is ammonia NH3, second one is SO2, third one is you can say Cl2, and fourth one is Br2. So, option is the first one. So, when ammonia is added to the Nessler's reagent, of course, the brown precipitate is going to come. Let me write the equation related to that. Solution for this, clearly I am going to explain. K2HgI4 is Nessler's reagent. This one is Nessler's reagent. This reacts with 3 KOH in the presence of ammonia. Of course, you require 2 moles of this, and then the product is going to come like this. The product is OHG2 and NH2. This one is a complex with I. Very, very important. This one is known as Millions base. Very important, Millions base, and this Millions base is actually the brown precipitate. this millions base will be coming here. So, we can write the structure of this millions base like this: CH2 attached to Hg attached to O, and that one is attached to Hg, and this one is attached to I. In this way, we can write this particular millions base, which is brown precipitate. So, dear students, ammonia is the X gas, which is on reaction with Nessler's reagent, it gives a brown precipitate. This one is also from practical chemistry. There are two questions which are coming from practical chemistry. So, I suggest all the students, please go through your practical notes and your practical examination points of how you are separating the table, what are the confirmation tests, which color is obtained when which gas is reacted with what, all these reagents and their formulae. So, keep them at your fingertips so that you can easily answer them. Okay then, students. Students, one more question from the acidic and basic properties of compounds from organic chemistry. See, all of you know, particularly talking about the acidic nature of phenols. Phenols are more acidic than the normal alcohols. Alcohols are less acidic, phenols are more acidic, because after giving the H plus, their conjugate base is going to stabilize through resonance. So, that is why phenols are far better acids when compared to the alcohols. And when we talk about acidic nature, Ka values and pKa values come into picture. Ka value is more stronger, that acid is, pKa value is less, more stronger the acid is. So, Ka and pKa values are opposite to each other. If Ka value is more, acid is having more strength, which is a strong acid. If pKa value is less, then it is having strong acidic nature. So, here they gave some pKa values to confuse you, and they gave some compounds. So, let us match the compounds, one more match the following, but this is from organic chemistry, acidic properties of phenols. So, let us go to this question. Students, observe carefully. I am writing the first options. First options is para-nitrophenol. B. Second option is meta-nitrophenol. Third option, this one is ethanol. Fourth option, this one is phenol. So, phenol and ethanol, which is a normal alcohol, are also given. So, they gave 10 here, they gave 16 here, they gave 7.1 here, and they gave 8.3 here. Remember, electron withdrawing group like NO2 increases acidic nature. Electron withdrawing group like NO2 group, nitro group, increases the acidic nature of phenols. So, let us see here. This one is the first option. There is phenol, OH group, and there is NO2 here. Second option, there is phenol, but NO2 is here. Third option, this is ethanol, C2H5OH. Fourth option is phenol, only phenol, nothing is there. But this one is in para position, this one is in meta position. Of course, this one is the least. So, we can say that least ethyl alcohol will have high pKa value. This one is pKa value, this one is acid. So, this one should have 16. The least 7.1 should be given to this. metanitro will come like this, phenol we have term. This is the options like this. So, para-nitrophenol is the best acid, then metanitrophenol is okay, but not as good as para-nitrophenol, because in para and ortho positions NO2 can show its most important electron withdrawing nature, and ethanol is having pKa very high. When pKa is very high, it's a weak acid, and phenol is slightly less than ethanol. So that's why it is a better acid. So this one is the question number, we can say this one is 15 question. So till now we completed 15 questions, dear students. Hope all these questions are very easy for you. Each and every question is based on different concepts. So as you are following our videos and as you are following our explanation, take your textbooks and your reference books and try to understand and study all the important points related to this acidic medium or basic medium or acidic strength or basic strength and organic compounds, their structures, practice them, and similar type of questions are about to come, so you can easily answer them with the inputs that you are taking from us. Okay, students? Namaste to all the students and parents who are listening to our videos and understanding the concepts and studying well. Best of luck for the students who are about to write their examination, and very good luck, and wishing the best result for the students who already attempted in the previous 2 or 3 days. So welcome students, I am SRIKANTH Sunil, expert in chemistry. I am a senior lecturer at the VISHRA IIT, JEE and NEET Academy. This is an exclusive junior college plus academy for the sciences, means the NEET aspirants or the IIT aspirants, anyone, they can take this route and they can come to us and they can take the admission. And in this admission process, we are about to tell about the career options, and we have highly experienced faculty here. All the faculty here are about 20 years experienced, and they are teaching at a particular position here, and they are well equipped with all the knowledge that can help your wards to achieve their goals. Dear students, most of the students after passing their 10th class examinations, SSC or CBSE, they will try to join in some or other intermediate college, wishing that the college will take care of their academics and everything. But in fact, most of the colleges which are around us, they are not so. They just advertise themselves to do this. This initiative of teaching all the question papers and explaining the concepts around each and every question, and in a very simple way, in a very simple English. We can also explain this in Telugu also, because we are all from the Telugu background, and we are also very good in our mother tongue. We can also explain this in Telugu also. స్టూడెంట్స్ ఈ పేపర్స్ ఏదైనా సరే మనం తెలుగులో కూడా ఎక్స్ప్లెయిన్ చేయొచ్చు, అలాగే టీచింగ్ కూడా ఏ మిక్స్ ఆఫ్ ఇంగ్లీష్ అండ్ తెలుగు రెండింటిని మిక్స్ చేస్తూ పిల్లలకు అర్థమయ్యే విధంగా అన్ని కాన్సెప్ట్స్ ఎక్స్ప్లెయిన్ చేసే విధంగా మా కాలేజీలో కోచింగ్ ఉంటుంది. మా మెటీరియల్ కానీ, మా కరికులం కానీ, మా షెడ్యూల్స్ కానీ, మా సిస్టమ్ కానీ మీకు అందరికీ ఖచ్చితంగా నచ్చుతుంది. ఇది గర్ల్స్ బాయ్స్ ఇద్దరికీ కూడా very very important adda for us, we can say, for IIT or JEE examinations and also for the NEET examinations. Every year we get a good percentage of students who get selected in IITs or NITs and even in the MBBS colleges, particularly the government colleges. Last year we got admissions into the Osmania Medical College in Hyderabad also, so which is a very good recognition for us. So students, first of all, main thing is manam IIT JEE examinations rayalante basics of this particular compound. We will stress on basics. మీరు ఇప్పుడు నేను ఎక్స్ప్లెయిన్ చేసిన క్వశ్చన్స్ అన్ని మీరు చూస్తుంటే అన్ని బేసిక్స్ నుంచి అన్ని ఇంపార్టెంట్ పాయింట్స్ కొన్ని ట్విస్ట్ చేసి ఉన్నాయి, కొన్ని డైరెక్ట్ క్వశ్చన్స్ ఉన్నాయి. సో ఈ డైరెక్ట్ క్వశ్చన్స్ కానీ ట్విస్టెడ్ క్వశ్చన్స్ కానీ మీరు ఈజీగా ఆన్సర్ చేయాలి. ఆన్సర్ చేసి ఈజీగా మంచి ర్యాంక్ తెచ్చుకొని మీకు కావాల్సిన కాలేజీలో జాయిన్ అవ్వాలని మేము కోరుకుంటున్నాం. సో ఆల్ ఆఫ్ యూ ఆర్ ఆల్వేస్ వెల్కమ్ ఎనీ టైమ్ to our VISHRA IIT JEE and NEET Academy and VISHRA Junior College. It is at Balapur X Roads, very near to the LB Nagar. LB Nagar location ki chala degra, some 3 kilometers from LB Nagar, and we have all the residential campuses here. Boys separate ga, girls separate ga residential campuses ఉన్నాయి. ఈ campuses-ని మీరు విజిట్ చేయండి. ఒకసారి మా దగ్గర ఉన్న ఫుడ్ అండ్ లంచ్ అండ్ స్నాక్స్ని మీరు అబ్జర్వ్ చేయండి. దే ఆర్ ఆఫ్ హై స్టాండర్డ్ అండ్ వీ ఫీల్ దట్ స్టూడెంట్స్ ఎవరైతే కష్టపడి చదువుతున్నారో దే రిక్వైర్ గుడ్ ఫుడ్ అండ్ న్యూట్రిషన్ ఆల్సో. సో ఎవ్రీథింగ్, అవర్ హాస్టల్, ఎవ్రీథింగ్ ఈజ్ దేర్ అండ్ అవర్ క్లాస్ రూమ్స్ ఆర్ ఎక్విప్డ్ విత్ డిజిటల్ ప్యానల్స్ లైక్ దిస్. డిజిటల్ ప్యానల్స్ అన్నీ పెట్టుకొని ఏసీ క్లాస్ రూమ్స్ ఉంటాయి. ఎన్ని అవర్స్ చెప్పినా సరే ఏమీ అలసట లేకుండా హ్యాపీగా పిల్లలు చదువుకునే ఎన్వైరన్మెంట్ ఉంటుంది. సో అందరూ పేరెంట్స్ కానీ స్టూడెంట్స్ కానీ ప్లీజ్ విజిట్ అవర్ కాలేజ్ అండ్ సర్టన్లీ యూ విల్ బీ ఓవర్వెల్మ్ టు నో అబౌట్ అవర్ కాలేజ్ అండ్ hope we'll see that you will come in the next academic year and join our college and I will be able to teach you personally on an offline basis. Bye students, have a good day and best of luck.